nombre es Jean, and this is all my Spanish. So this is my blog, gcm.com, and I also write some things on Twitter. You can find me easily with that handle. So I'm from Brazil, and that's my beautiful city. I live in Porto Alegre. It's kind of near, and we share a lot of things in common. So yeah, it's good to be here to eat some good meat and enjoy with friends, and it's been awesome. So yeah, I work for a company. The name of the company is Work and Company. We build digital products. We are based in New York, and we have many different offices around the world. So that's the company. So yeah, if you want to check it out or talk more about that, I will be here to discuss also about this and how to build digital products and all this stuff. Okay, but let's go to the subject. What is a type? That's the reason that I am here. So if you get many different values, many different things, you start to look at it, and you realize that there's some things in common here. So you can make a group. This is a number group and also a string group. You can see the difference between. So a type it helps to group similar values and perform different operations. For example, if you get numbers, you can multiply them. But it's not so easy to multiply strings. Okay, you see that sometimes we did, but okay, it's not good and it's not right. JavaScript brings many different types. And there's like a very clear difference between these. So there are the primitive types and also the object types. So you have string, number, undefined, new, Boolean, symbol, and also how many different objects, and also the same objects that we have in the primitive types for some of the primitives. So, and that is very important. Okay, so it's kind of odd the way that we treat types in JavaScript and values in JavaScript in general. For example, we have 0 and also new, and also not a number, and oh, there's an undefined too. No, that's not defined. It's not a good joke, sorry. So yeah, but the point is that types are a significant part to understand the language and the way that we write code. It's very important to understand the types of a language for that. For example, primitives are immutable in JavaScript, and we don't have properties on primitives. And also, objects are mutable, and we have properties. And that's the trick. There are some objects that wraps a primitive to bring properties for that. That's the way that we can access the length of a string, for example, using this wrapper. So it's all about types. Okay, I'm sorry. So okay, but why you should care? I mean, what's the relation between types and errors, for example? That's important. We want to make good software, and we want to be better programmers. So what's the relation between types and errors? So first of all, let's get this as an example. So this is our product. A product have a name and a cost and tax, and also a price. That's a calculation between the cost and the tax. And that's it. We can easily understand. I mean, if you look at it, you see that this is the types involved here. So that's the class of our product with a constructor and a price calculation and everything. That's it. Okay, so if you try to like create a new product, you create something like this. But then we made a mistake. So we made a typo. We tried to access the prices, not the price. So we received that famous phrase. I mean, I struggled many years to understand that phrase. What is undefined is not a function? What's the meaning of that? I just know that it's an error. I mean, you try to treat something that is undefined as a function. Maybe this is the most famous phrase on computer science nowadays. But okay, so, but now there's no this error anymore. The browser evolved and the error is something like this. And what's way better than the other one. Okay, the point is that JavaScript and types have problems, and it's a headache to deal with it. For example, if you have a product and you just forget the new keyword to initialize it, so you just pollute all your global object with properties, like you are doing here. You put a name on the window, you put like a cost on the window, and all this. So it's a problem. And what brings us to the common mistake, the most famous mistake in JavaScript, that is incorrect reference to this object. So that's a big problem. And also, if you look at very old codes, if you are an old programmer, you probably see something like this. They try to make sure that this is an instance of the constructor that you are like defining in that moment. So this is like old code. And okay, if you just try to call product without a new. Without a new, you see something like this. You see like that exception, that error. It's just to make sure that you don't pollute the global scope. Okay, so but now I mean, the language evolved again. The language evolved. So if you are writing strict JavaScript, you will not see this error anymore, because if you have something that is a constructor with a capitalizer letter, you can call it as without a new operator like this. Or because you can like put you can have like this relation between this and undefined and global object. I'm sorry, you have like this related with undefined on strict mode. And also, if you're writing a class, you can actually call it without a new as well. So the language evolved a lot. Another common mistake is to pass like a string in an object that you need a number instead of it. So that's another problem. And this is the silent error, and this is the worst error that you can have, because now you just turn to not a number, and you don't know why and how to calculate. Another common thing is try to mutate something that is immutable. For example, strings are primitives, and primitives are immutable. But you can do something like this, and nothing happens. You just like, I don't know what happens here, but anyway, there's no way to mutate a string in JavaScript, and there's no error for this kind of operations. But if you define something without defining it, if you define a new variable without defining the value and try to access it, you access a property for undefined, and then you see an error. So yeah, it's kind of tricky. Okay, there's many errors. That's a simple list of some of them. As I said, the silent errors are the worst, in my opinion. But okay, you have many errors. Okay, this happens because JavaScript is a dynamic, weakly typed language. That's the reason you are writing in a dynamic language, and those are all typical examples of runtime errors in dynamic language. You see that in Ruby, you see that in Python, you see that the same errors all over the dynamic languages. Of course, in different forms, in different ways, but it's the same. Okay, so why not type check? Why not prevent that? And okay, if I show you a list of like these instructions, you easily see that and predict that this will fail. It's easy to understand that it's not right. I mean, there's no way that this will work correctly. This is all no sense. But if I show something like this, you don't know what text is carrying and what price is carrying, and it's difficult. There's no way to predict that this will be a good or bad code. Okay, so let's introduce something new. That's our guide right now, Flow. Flow is a static type checker for JavaScript. And what this means, it means that it can check your code without running it. It's simple like this. And we already know static analyzers. For example, we use JSHint or ASLint or all these lints. So it's the same principle. We are like trying to understand our code without running it. It's the same point. Okay, so let's get our product again, and let's make clear the types. And that's the way that you can do that using Flow. You just define the properties and the kind of types that you need that's our contract. I mean, properties and its expected types. Okay, and if you write something like this, the flow analyzer you tell you that it's not right because there's a type incompatibility. So very straightforward. And if you are using something like Atom or another modern editor, you see like in many different ways, it's easy to understand why you are writing code. You see that it's an error like this. There's also TypeScript. That's another language, but it's very similar to Flow. And that's a way to write the same code in TypeScript. So you have to define more in more different places the types, like you have to define in the constructor as well. But the principle is the same. It's not a big deal. Okay, but what are the different types that you can put in your code to define like how it works? So you have all the primitives, all the objects. You have literal, so you can like define that this is a specific string that should be used and this kind of things. And you also have some advanced types. You have any, for example, that means that that variable can have anything. Nullable or maybe, it's like it's a product or null, for example. You can use union and also intersections. That's very powerful. But the one that I like more is this category of types. So it's the fancy types. So you can define like a new type, and this is very good. You can say that, look, that the cost is a number. So you can use like cost all over your code. You can define interface and also generics. Interface is like, you can define the kind of methods that your code you have, but generic is more complicated than that. You can say that, for example, an array have different values, and for example, you can say that a promise will return something that is like a number. So that's the way that generics works. It's difficult to explain. I'm sorry for trying it. But okay, so the point is, also, when you define new types, it helps to understand your business. So if you define a cost, for example, you kind of start to understand the way that your code is working and what this code is about. And for example, that's a way to define our product. For example, if you receive that as a return from any API, as a response of an API, you can see that, oh, there's a product, and the product is like about these properties and these values. So it's better to have a code like this to understand the entities. Okay. Also, type signature allows you to foresee problems. What this means, for example, if you try to annotate a function like this, and you see that that function returns a number and a string, and also an array with new. You kind of start to understand that this function is not good, because it's too many different values. There's no point to have a function like this. Maybe you are doing something wrong, just maybe. So that's the point. So this is like a type smell. So because of the types, we start to understand this kind of things as well. And there's also a good tweet about it that says that a type system is first and foremost a communication mechanism. So this is something interesting. You can replace direct communication by using types. And for example, if you're running a big team, you can just look at it and understand better the code that your coworker just wrote, for example, because of the type definitions. So this is important. So we can just code without communicate with anyone. That's a good point. Of course, it's not. Programming is about communication. Of course, you have to keep like communicating. Okay, but we're just talking about like how to define the types inside of your code or code base, but there's also external types. Because we are writing interface, we receive a lot of data from the server, from the user. It's more about external data than internal data, let's say. And okay, how can we address this? For example, in TypeScript, if you go to the documentation of Angular, for example, Angular 2 plus something, it's all about TypeScript. So you see something like this. So here you are defining that some response will match a specific contract. That is like, I receive results, and this results is strings, is an array of strings. That's the way to define that in TypeScript. Okay, that's cool, that's right. And then we receive something like this. So yeah, it's right, it's results with strings. It's working. But if you receive something like this from your API, I mean, just a crazy guy goes and make a deploy during the night and change the API response. So that kind of things happen. So yeah, and then it's like this. You say, okay, trust me, you return something. But then, yeah, kind of a bad joke. But, okay, the point is, static analyzer works if the contract is respected. You have to follow the contract, so if you don't follow, error. And why that happens? I mean, what's the way that the type analyzer works to address external response? And any is the answer. For example, you have like this type definition that is any, and based on that, you can turn your value for whatever you want. Here, for example, we get a value, and we are saying to the analyzer that this value is any, so, and we assign null for it, and then we just saying that, okay, but now it's a number or it's a string. So this is valid code because we started with any. Any is the problem here. So any is the bad guy when you are using static analyzers. But using any is completely unsafe and should be avoided whenever possible. This is like a quote from the flow documentation. But if you look to our definitions of APIs from JavaScript that brings data from abroad, you see that it's about any. Everything is any. A promise return any. HR request returns any response because we don't know. So the way that we communicate with the outside world, it's using any. So that's the problem. And what brings us to the runtime exception? That's the case of like broken data not being handled. That's as simple as this. Okay, but if you look around in the JavaScript universe, you see a language like a new language that's called Elm, and it's a static typed language for web apps, and that's the thing that takes my attention. There's no runtime exceptions. There's no way to run errors in production. So, what's the point? So it's magic. So, okay, and let's see if it's right. So that's the guy that advocated a lot about that language, and that's a tweet from him, and he said that that's never happens an exception in production. So yeah, this is like impressive. Okay, that's the language. You can find it and read more about it. Okay, let's see our product on that language. If we change and write our code on that language, you see that it's pretty similar to the way that we define our data before. We just define the product and say that that's the properties and also the types. And you can define like a function that calculates our price. It's not an object-oriented language, so it's more functional. You see things like this. It's more functional. It's pure functional. So you see things like a lot of functions. But it's okay. We can barely understand it. It's not so difficult. And the point is that the language is almost about type annotations. You see many type annotations, and okay, it's okay. That's our example using the product just to like get a bit of the way that the language works. It's pretty similar that the way that we wrote code before. Okay, but what's the way that it handles like no exceptions? What's the way that they achieve that? And it starts with that guy, the code, the JSON decode. So any time that you want to decode a JSON, you have to define the properties that this JSON contains. For example, here we are saying that there's a field with results, and this result contains a list of strings. It's the same that we did on our API before. So if we just try to decode something like blah or foo or something like random like this, it will give like an error. So it's an error and like giving an invalid JSON because it's not like what we try to decode. It's not respecting the contract. So if we send something that is valid for our contract, it will decode and give us the OK value and also the list of strings. So yeah, that's the beginning of the solution. So how we program something like a request and response on that language? So that's our start. You define that it's a request, and also we receive the response. You receive something that is new, that is this result. And the result can be OK or also an error. So anytime you write something like a request response, we have to create the OK case, what means that everything's gone right. I mean, the result is correct. And you have to address the error, what means that the result is not correct. So if the API changed the contract, you have to address it in the error case. So you like say to the user that there's no data or something, you have to figure out. And okay, the result is the answer, because the result wraps any computations that may fail. And a request and response is a computation that may fail. And this is a great way to manage errors. There's no exception in that language. There's just this result. That's the way to treat it. And the good point about result is that you can pass to another function as a value. It's a value. It's better than an exception. The problem with exceptions in the language is that it broke everything. It's like a bomb inside your code. So that's the difference between like dealing with errors with exceptions or values. Okay, so there's no exception in Elm. The code must cover all edge cases. You must cover, the compiler will ask for it, and that's it. Okay, so, but a guy, and I wrote an article about it. A guy asked if, okay, but Flow and it's like, and others like TypeScript, it can prevent missing case like Elm compiler does. And the answer is yes, it can. I mean, if you are not dealing with data from abroad, it's okay. It's easy. The flow analyzer will ask you to handle this case. So we are kind of getting in the point of Elm, but we just have to treat this new point. So, and okay, let's try it. We don't want to move on from JavaScript. So how we can change our code to be like Elm without writing Elm? So yeah, let's see. Okay. So it starts with a library. The name is tcomb. When you're writing code with tcomb, you can define like the contract. You can define an interface, and you can see that, okay, I need a result, and this result is a list of strings. The same thing again. So if you process something like this first example, it works okay. If you send something different, like a number, it will throw an exception. So we are starting to analyze the code at runtime, analyze the types at runtime. So that's the point here. And okay, there's also a Babel plugin that you can turn like your flow code into this tcomb pattern, so you can mix both. It's kind of experimental, but you can like try to like put this together. And also, I tried something different here. I tried to recreate the OK and error. I tried to recreate the Elm result. And this is a good example if you want to check it after. So you can like mock the same thing. You can create the same thing using JavaScript. It's just a matter of like being of doing it and like being like attached to it and not like changing this in the going work. So okay, so that's the point. And the final thoughts about this is we should focus on our efforts to avoid or fixing the corner case on our code. So that's a good article that's trying to like make a point about coercions in JavaScript, and the article itself about we have to understand the coercions and make it work instead of just arguing and say that JavaScript is bad and the language is bad and all this bullshit. So this article is very good. Okay, so the code needs to cover all the possible cases to avoid runtime errors. That's the point. It's not a big deal. Type annotations and runtime type checking that we see like just a minute ago are great allies that help with that task. So it's a good way to start to deal with it. It's an easy way to deal with types in JavaScript. And that's it. I hope it inspires you.
Thank you. Thank you. Thanks, John.